there. So last week we were playing around with descriptive statistics, mean, median, mode, standard deviation, all those quartiles, box plots, and histograms. It's quite a lot of stuff last week. We repeated quite a few things. So the histogram we made in week 1, we got to do it again in activity 2 and again in share your work. My hope was that on the share your work, that you actually talk to each other like I asked here. But generally, no matter how hard I try, I have a hard time getting people to talk to each other. Did any of you guys talk to each other about the what you saw in the data? I guess silence is a no. Okay. I find that it helps to talk to somebody else about stuff like this. So previously you had done either the Pendleton or the Hermiston data, made a nice histogram, calculated the summary statistics, looked for outliers, and then you talked about what you saw. So I was expecting you to write a paragraph or more, 1 to 2 paragraphs telling me what you saw in the prices for Pendleton and Hermiston, how they are alike and how they are different. So I've graded all the other stuff. I haven't graded this one yet. I was holding off waiting for a couple more people to submit. So we'll see. And then you can see everybody else's submission here. So if you want, feel free to go check and see what other people saw. And if you have questions, I don't think anyone wrote to me about questions on this activity, but if you do have some still, make sure you let me know. Are there any questions at the moment? Okay. Other thing, you may notice some colors in Canvas. I added these today because I was bored with the plain grayish colors in Canvas. I wanted to lighten things up a little bit. So, colors in Canvas, fun stuff. All right, so this week we are looking at sampling and distributions. So kind of an overview of what that's about. Hopefully you started the reading on that. So we've been doing these descriptive statistics, this data analysis, but in order to have the data, we have to collect it, and that's what sampling is about. And there are good ways of collecting data, and there are bad ways of collecting data, and then there is just collecting data. If you want to use the data for any real purpose, like making decisions in a business or in a government or personally, then you want to collect good data. And one way to do that is with an idea called random sampling. Random sampling is harder than it seems, because being random, it turns out, is very hard. And so one question is, what does it mean to be random? It turns out humans are not good at it. So in order to make a random sample, we have to implement some kind of technology. And the technology could be super simple, like pulling names from a hat. Oops. Or drawing cards from a deck, or rolling a dice, like we looked at with probability. But we can't rely on humans to be random because we have biases about everything. So these are the pretty simple technologies we could do. The book shows some examples of using a spinner. Spinners are pretty fun things to do, especially activities with kids. For us, we're going to use a computer to be random. In particular, we're going to use a spreadsheet. And we'll take a look at this in just a second. The spreadsheet gives us basically two options for being random. One is what's called RAND, parentheses, and the other is called rand between. And random, you don't really have to do anything in the parentheses, but rand between, you need to give it two numbers. So you got to give it some starting number and some ending number to work with. And so let's just take a look at a little spreadsheet randomness for a second. In one of my spreadsheets. And you're going to have to do a little bit of spreadsheet work, not too much in this section, not as much as the last one. Oops, stud. It's supposed to be stuff. There we go. Blow this up a little bit more. So again, the randomness in a spreadsheet, there's one function we can use called rand. And anytime we use a function in a spreadsheet, we got to type equals first. If I start typing rand, it gives me all the random functions it has. We won't be using rand array. I'm just going to stick with the simpler ones, rand and rand between. So rand, it says picks a random number between 0 inclusive and 1 exclusive. That means we could get 0, we'll get numbers up to 1, but not 1. So it could be we get like 0.999999999. Eventually, the spreadsheet runs out of digits to work with. And so we just rand, start parentheses, close parentheses, enter, picks a random number. Anytime you do something on the sheet, like type something else, it's going to regenerate anything that's random on the page. I can take that random number and I can fill it down. And I can get a bunch of different random numbers. And these random numbers are going to be between 0 and 1. It's possible to get 0, it's unlikely, but it's not possible to get 1 from the function called rand. Lots of uses for it, in particular doing simulations, which we'll talk about later. One way I use it sometimes, if I have a list of names, let's get a couple more in there. Okay. So some friends of mine and me, if I wanted to put these names in a random order other than like alphabetical in some way or some other ranking just to be random, what I could do is I could sort by that random number column over there. So if I highlight all the data, I can go to data, sort range is the one I want, that fifth option, has a header row, and then I just say sort by the random number. Now, two things are going to happen when it does that. It's going to resort according to the random numbers in the current column A, but since we've modified the sheet, it's going to recalculate those numbers. So I'm going to get new random numbers at the same time. So right in a row, first it'll sort them, but then it'll change them, but I will get a random order of the names. So if I hit sort right now, they're in a new order, but notice these random digits aren't in order anymore because once it sorted the spreadsheet, it said, oh, new random numbers, cool. So that order of operations is a little weird, but I have a new random order. So often in some classes, I'll put the students in random order, and then I'll just ask people questions in that random order. That way, like, if your like last name ends with an A, it kind of sucks if you always are the first person asked a question every day in class. So I can throw a little randomness in how I pick on people. And there's other ways we could use that too. Let's look at rand between. So rand between just works with whole numbers. So if I start typing rand again, it gives me the three main random options. This time rand between gives you a random integer. So integer could be positive, negative, but it's a whole number between any two integers you give it. And inclusive means it could be one of those numbers. So very simple, if I did rand comma 1, 2, that's either going to give me a 1 or a 2 randomly. Oops, what did I type wrong? Oh, I forgot to type the whole function. Rand between, there we go, 1 comma 2. There's nothing in between, so it can only give me 1s and 2s. So if I click on that and fill it down, I can only get 1s and 2s. It could be, I want to do a number between 1 and 12. And again, every time I change something on the page, like if I type something new, it's going to pick a new random number. If I delete something on the page, it's going to pick a new random number. Or I could get a whole bunch of them. Oops, I missed. And one thing to note here is numbers could get picked the same time. So it's like it has a deck of cards and the cards are labeled 1 through 12. It shuffles the deck, looks at the bottom card, writes it down, reshuffles the deck, looks at the bottom card, reshuffles the deck, looks at the bottom card. So notice we got 3 here, but we got a 3 again. We got an 11 here, we got an 11 again. So it's not a unique drawing of the numbers 1 through 12. The same number could appear again and again and again, just like when you flip a coin, you could get multiple heads in a row. So this is an idea of a random number generator. So spreadsheet is one way we can get them. When you read the book, you'll see that they talk about these random number tables. Those are pretty much outdated now because we have computers on our phones or computers. We have computers in front of us all the time, and any computer can easily grab a random number generator like a spreadsheet or some other app. So another source of random stuff, one of my favorites, if you just search for random, oops, if I could spell random, is random.org. And random.org is a computer company that just specializes in trying to make randomness happen. Yes, let's see. We use cookies, thank you very much. Allow all, sure, why not? And they've got a bunch of different things they do. They just have this simple random number generator where they'll say, hey, I'll generate you a number between 1 and 100. Or just like I did in Google, I could say, give me a number between 1 and 12. And they spit that out. But they also have lots of other ones to use. So like they have a random dice roller, a random card shuffler, a random coin flipper. I can decide how many dice I want to play with. In this case, I use this site once in a while just when I'm demonstrating things online through videos to people when I can't be physically with them. Otherwise, I'd much prefer to roll real dice. And even Google has gotten in the game. If you search for random dice. Oh, come on, Google. It used to pop up. Random dice roll. Ah, huh. Interesting. So when I used to search for this, Google used to do it for me, and it used to bring up these random dice that would appear on the screen. Huh. I'm sure I used to search for random dice roll. Okay. Google must have disabled it or something. Oh well. So random.org is a place that has a lot of different random stuff. One reason I point that out is most people misuse the word random. And just an example, I was talking to my sister the other day and she said, oh, I met this cool guy the other day. It's just this random thing at this bar. And a lot of people use the word random in ways like that, but it's really not what the word random means. There was nothing random about her going to that bar. There was nothing random about that guy being in that bar, right? They were all there for a reason. And randomness is kind of without reason when something happens and probability is involved. And so that was a misuse of the word random. And we use that all the time. I do too. But if I asked you, say, hey, give me a random number, you're going to think about it and you might just pick 1 because it came to your mind easily, or 7 because it's your favorite number. But our brains just don't work that way very well. Our brains are very organized. And so being random is a challenge. Um, so if I asked you guys to give me a whole list of random numbers between 1 and 12, maybe I say, hey, give me 20 each. What I would find is there'd be a very different look of the numbers you gave me than what the computer gave me here, that you guys would be biased towards some numbers and biased against other numbers. And just more on the rand between, right? Oops, I gotta type equals first. Let's go down here. Again, it works with integers, so you could even do negative numbers, like maybe I want either -1, 0, or 1. So I could say, give me a random number between -1 and 1. It's going to give me an integer, so that when I replicate that by filling it down, I'm either going to see a -1, a 1, or a 0. And if I do this enough times, since I only pick 3 numbers, that I should see about as many -1s as 1s as 0s. Okay, so it's producing what's called a uniform distribution. We'll get to distributions in a minute. But this is super important, that humans are not good random number generators, that we have to use some kind of technology. And the technologies that we have access to at the moment are pulling names from a hat, drawing cards to do something, rolling a dice to do something, spinners, or using a computer to do it. The book talks again about these random number tables, which you'd have to look up in a book, but it's way easier to use a computer these days. So I'm not going to follow the book's advice about using a random number table. Okay, more on random samples. As far as sampling and randomness goes, in order to have a good sample, we want 2 things to happen. We want the sample to be a random sample. There's many types of random samples. And we're hoping for a representative sample. So what I mean by that is it should be like the population in some way. So for example, at BMCC, we have slightly more female students than male, but it's pretty close to 50-50. And so if I did a random sample of students and they were all female, then my sample is not representative. I'm missing an important part of the population, the males. It could be age that I'm thinking about in terms of representation also, that we have slightly more people in their 20s than we do have people in their teens or their 30s or their 40s. So when I run my random sample, I want my sample to be similar, slightly more people in their 20s than in their teens or 30s or 40s. So representative in this case means be like the population. In terms of diversity. And there's tons of different ways a population is diverse, from age to gender to likes to uh, areas people study, if we're talking about college students, where people live, lots of things like that. Turns out it's pretty hard to get a random sample, you got to work at it. The easiest type of random sample, sort of, or the simplest, is called a simple random sample. And let's suppose we're looking for a sample of 100 people. So example, n equals 100. That's the sample size. If the sample size is 100, then any possible group of 100 people should have the same chance of being selected as every other group of 100 people, is what it means to be simple. So any group of 100 people should have the same chance of being selected as any other group of 100 people. So that's the idea of a simple random sample. Now, there's nothing special about the 100. It could be I'm looking for a sample of 3 people. So any group of 3 people should have the same chance of being selected as any other group of 3 people. So this is really for any sample size. I was just using 100 as an example. Now, one problem with a simple random sample, in order to ensure that everybody has the same chance of being selected, that means you have to have a list of all the people. Oops, for a, sorry, simple, not sample, for a simple random sample. Sometimes this can be easy, but sometimes it's not. So an example for me that would be easy, if my population was BMCC students, current ones, well, I can easily ask for a list of all students that are taking classes right now. That's not a problem. So this one is doable. What if the population, a couple of you live in Pendleton with me, was Pendleton residents? Do you think a list of everybody living in Pendleton right now exists? If so, where would I find it? Anybody still with me? You guys live out there? Chat is empty. I hear no voice. Did I put you to sleep? Hello? Hello, anybody there?
I am. I think
Oh, good. You're alive. Thank goodness. I was getting worried here. Sorry. I know this is kind of boring. So what do you think? Is it easy to get the list of all the people in a town?
I'm probably not look up their name, but you could probably just look at the population, but that would be the only thing that you could probably find easily.
Where would you get the population?
I would just Google it.
Okay, let's Google the population.
I was gonna say I'd probably Google it too.
All right, let's do it. Okay, so Pendleton, Oregon, Oregon population. Let's see, in 2019, Google thinks there were 16,733. Where did they get that? US Census Bureau. Okay. I don't remember anybody asking me if I lived in Pendleton in 2019. So where did they get it? Did they miss anybody? Like my daughter in 2019 lived with me for a couple of months, my older daughter, because she got, she was in between high school and going away to college. And did they count her? I don't know. So even this population, it's an estimate, right? They don't actually have a list of people they're checking off. Oh, look, Gary's here and Julia's here and Lauren's here and Avalie's here. And so it turns out that I don't think I can find that list. And if I did, it might miss some people. What does it mean to live in a town? All right, so back to my notes here. I don't think I could easily get this list. If I can't get the list, I can't get a simple random sample. Here's another example. My cats are in love with squirrels. So I'm wondering if a population of squirrels in my neighborhood. Do you think it is possible for me to make a list of all the squirrels in my neighborhood? Probably not. They're hard to catch. So just because we have an interest in a population, we want to do a sample of the population, doesn't mean we can get a list of the population. Think about fish in a pond. How would you ever get a list of all the fish in the pond, right? You have to try to tag every single one of them, which is, it's just not feasible. So simple random sample is a good idea in theory. It works in some situations where you have like a place where people had to register, right? We have student registration, so I can look them up. That's not a problem. But when I move to a town, I don't have to register anywhere, right? I say, hey, I want to rent an apartment from somebody. They just rent the apartment to me. They don't record it anywhere. Nobody comes around collecting that information. So it turns out it's actually pretty hard to get populations of people, populations of squirrels, populations of just about any living thing, and even non-living things. It's kind of hard. Okay. So simple random sample is a tough thing to get, but we can get it sometimes. Okay, what are the other options? So other types of random samples. And it turns out this is just a really hard problem. Sounds easy at first. Oh yeah, I can go get a sample, but getting a good sample, that's really hard. It's doable though. We've been studying this for a long time. So there are whole courses just designed, just about how to design a sample to make sure it's got some randomness to it, it's representative, it's not biased. So one that the book mentions, oh, what's that? Thought I heard a voice there. Question? Okay. Stratified random sample. So a stratified random sample is where we split the population in groups. And then we select proportionately from each group and randomly. And I'll give you a couple of examples of this. So two things need to happen. First, we get to decide on some way to group the population. Second, we need to proportionately and randomly select from each group. So let's go with the BMCC students for a minute as our population. And let's suppose I want a sample of size 20. And for my groups, I'm going to choose gender, and I'm going to go for male, female, and other. And in order to select proportionately, you have to know something about the population. So previous populations of students, I suspect that I'm going to have about 48% male. I'm going to have about 51% female, and then I'm going to have 1% other, where they didn't identify with male or female, they just refused to tell me. Okay. So that means when I make my sample, I want about 48% of my sample to be male, and about 51 of my sample to be female, and about 1% to be other. Now, one thing to think about with a sample of size 20, one person out of 20, if you think about that for a second, multiply top and bottom by 5, that's 5 out of 100, or 5%. So a single person here would be 5% of the sample, right? So can I really do a 1% other? 1% is pretty different from 5%. So it could be, well, maybe I'm just not going to have any others. And 48 and 51 are so close, given that one person is 5% of my sample. I might just be stuck saying, we're just going to have 10 males and 10 females because it's close enough, right? Practically, I can't exactly get those. Right, so maybe I go back to my boss and I say, well, I'm having a little trouble with the sample you wanted me to take because here are proportions, but you only wanted the sample size of 20. And then I say, well, what if we raised the sample size to 100? So what if we did n equals 100? Then I can say, then we should get 48 males. Right, then it becomes a little easier. 51 females. Oops, I messed that up here. Females. And one person that identifies as other. And of all the people of other, I'd only want to randomly select one of them. Of all the females, I would have to randomly choose 51. Of all the males, I would have to randomly select 48 of them, excuse me. So that's the idea of proportionately. We have to already have a guess about the population distribution. Right? I have to know something ahead of time in order for that to happen. So that's one way we might do a stratification. Another example of a stratification is age groups. So if I stick with the same population that I've been working with, students, often a common way to group people by age would be to do something like get the people in their teens, so 10 to 19 years old. And then the people in their 20s, 20 to 29-year-olds, the people in their 30s, 30 to 39-year-olds, people in their 40s, 40 to 49, and so on. Let's do a couple more, 50 to 59, 60 to 69, and then 70 plus maybe. It's a common way to go about doing it. So then I would need to know what's the frequency of people in each of these ages, right? We made frequency histograms last 2 weeks. So in order to do a stratification by age group, I need to know some data about that. So let's suppose as far as the 10 to 19-year-olds, maybe that's only about 5% of my whole population from previous data. 20 to 29, that's probably most of the people I deal with. So maybe that's like 40% of the people students we deal with are 20 to 29. And then maybe the next one's 30 to 39. So maybe that's like 30% of students are in that range. What am I up to? 75. Maybe there's like 5% here. What do I have to do? 25, or maybe we'll do 15 there. Where am I at now? 80, 90, maybe 5% there, 3% there, and maybe 2% there. So hopefully those add to 100%. So when I make my sample, I would want to choose proportionately here. And then we have to realize that a sample size may not fit perfectly with these percentages, and then we got to fiddle with them like we did before. So if it was super easy, they said, hey, I just need a sample of say 50 students, okay? So suppose n equals 50. N is always how we state the sample size for a variable. Then I would want to know, well, what's 5% of 50? Well, as far as my counts for my sample, 5% of 50 would be 2.5. 40% of 50 is 20. So I'd want 20 people there. Now I can't have half a person. I'll worry about that in a minute, right? These are the number of people in my sample in each age group. But I would have to take the percent times the number to figure out what I'm doing. 30% of 15 or 50 would be 15 people. 15% of 50 would be 7.5 people. That half a person again. 5% of people, of 50 people would be 2.5 people. 3% of 50, 1.5 people. 2% of 50 is one person. So then we have to go back and say, what do we do about these half of people here? And so then we just have to make a decision. We can't round them all up because then we'll have more than 50 people. Or maybe we decide, oh, just heck with it, we'll just round them all up. So we have choices to make. So there's different ways you could go. You could just say, hey, I'm just going to do 2. Then you would, if you rounded them all down, you would have less than 50. So again, choices happen. Nothing works out perfectly. So maybe I'm just going to say, let's just do 3. Let's do 8 here. Let's do 3 there. And then let's do 2 there. Then what's going to happen is, because I overestimated in some of the cases, I'm going to get what, 1, 2 extra people. I think if you add that up, it's going to come out to 52. So I have a little more than 50, no big deal. Am I exactly meeting these percentages? The answer is no, because I can't do a half a person, right? So there's always choices that have to be made. But the point here is a stratification is a grouping. You have to select proportionately from each group. So again, this would be an age stratification. Right, we just split the population up into groups some way and pick from there. So that's a common way samples are done. Again, randomness involves in how do we pick the 3 people from 10 to 19? They would have to be randomly selected somehow. How do I pick these 20 people that are in their 20s? I would have to randomly select them somehow. So we have to identify and randomly select. So don't forget about that. Still need random selection. The book only mentions stratification as another way to do a random sample. I'm just going to mention a couple of others just because they're out there. There's another kind of random sample, and there's actually many more, but I'm just going to do 2 more. Clustered random sample. So the way a clustered random sample is, often it's done geographically, but it doesn't have to be. So it could be neighborhoods in a town are the clusters. So it's still grouping. So let's say here's my town, and each square in my grid right here is a neighborhood. So this is 1, 2, 3, 4, 5 by 4. So there are 20 neighborhoods in this town. All right, so this square again is my town. What I would next do is randomly select some neighborhoods. So maybe I number the neighborhoods 1 through 20, and I choose randomly 3 of those. So I would pick this neighborhood right here, maybe came up randomly, this one came up here, and maybe that one right there came up as my 3 random neighborhoods. And then I select all in each of those groups. You may have been in a class where you're asked to take a survey and they kind of took up the whole class to do so. There's a survey we do like every other year around here called the CENT survey, which is a national survey of college students. That is a clustered random sample in that the college or university is asked to randomly select some classes, but then every student in each class selected must fill out the survey. So if you don't show up to class that day, then someone's going to track you down and have you fill out that survey. So that'd be another example. So then we would need to survey each and every student in the selected classes. All right, so there's numerous other techniques for sampling. I think that's a good start. Getting back to an idea I kind of mentioned earlier. Let's see, not there. Here. An important idea was the idea of being representative of a population. And that kind of relates to the way people are distributed in the population. And the distribution means a lot of different things. So I just want to relate it back to some ideas we've played with before. Oops, wrong button.